Okay, welcome everyone to the Manchester Java community today. Today we've got Billy Korando from Oracle. He's a Java developer advocate, so welcome, Billy. He'll kick off with his talk in a few minutes. Just before that, I just want to say thanks very much to our sponsors, RecWorks. They help us out a lot when running these events, so we appreciate that. And also, for tonight's talk, if you've got any questions, please drop them into the chat, and we'll make sure Billy sees those as we go along. So yeah, over to you, Billy. Thanks.
All right. Thank you for that introduction, and thank you for the invite to speak at Manchester JUG. Been looking forward to it. So, as mentioned, my name is Billy Korando. I'm a Java developer advocate with Oracle, and to this presentation, we're going to be looking at how to be a Java automated testing superstar. A few things. So, I am a demanding speaker, and I ask that you please ask questions, at least when I'm giving a presentation, just because sharing like the mic could be kind of weird for maybe. Just post them into the chat. And so Nick said he'll be checking with it, and I'll also be sure to be watching the chat as well. So if any questions do come up, I'll be more than happy to answer them at the time, because after all, the reason I'm here is to help you learn about automated testing in this case. The major link to know about is the link to this presentation out on my GitHub. So I'll also get this updated here after this presentation. I forgot to do it a little bit earlier, but I'll get it updated to make sure all the slides match up with what I'm showing in this presentation. And of course, don't hesitate. Please reach out to me at Twitter at Billy Korando, or you can also email me, billy.korando@oracle.com, if you have any questions after this presentation. If you leave this presentation with an intense desire to know more, we actually have a lot of great materials for learning. So we recently, last month, launched dev.java. And so we have a lot of great tutorials on various dev topics. Actually, one area we need to get a lot better at that we haven't touched too much yet is on automated testing. But for a lot of other features and concepts within Java, we have a lot of great information. Then there's also Inside Java, and this is a good place to get to know about what's actually going on within the world of Java from the perspective of Oracle. So we'll bring on like Java, like the actual developers of the Java JDK on to kind of talk about like upcoming projects like Amber, Valhalla, Loom, and so on. Just kind of explain what's going on there. We post a lot of content to our YouTube channel, and actually just about an hour ago, if you know Nikolai Parlog, he actually just released a really great video that's very funny, that covers some cool things from dev.java and just some really good information about some new recent features that have come out from Java. And then last, there's also, I post every Monday, Sip of Java, where I give like a 1 minute on various Java topics that usually a little bit uncovered or maybe just newer stuff. And then also we have Jet Cafe by Jose Palmard, who covers various JEPs that have been recently released. So definitely all good kind of content out there that we like to share and to help keep Java developers informed about what's going on in the world of Java. With all that said, let's actually get into our actual presentation. And the first thing I kind of want to cover is why write automated tests. Presumably, most people here have already kind of bought in on the idea of automated testing, but I still want to cover this part because maybe your organization hasn't really bought in on it. Because I know a lot of organizations I've been at throughout my career, maybe they kind of view this automated testing thing as some sort of academic concept, like, oh, we should be doing this, but real world, you don't necessarily need to do it, and you never really get to the point to writing automated tests. And then you also have to consider that it is a substantial time and effort to write tests, that for a real quality automated test suite, you might be taking as much time to write the test for it, if not more, as much time spent writing tests as you do the actual production code, if not even more. And also, as you write all these tests and your code changes, it's going to take a substantial time and effort to maintain the tests. And if your code is like me, I've never written a bug in my life, and I'm sure no one else here has written a bug in their life. But why are we going to do that if our code is perfect? So why should we take all this time for writing tests? So I'm guessing most people here have heard about continuous integration and continuous delivery or deployment, CI/CD, and I'm sure it sounds really cool. And maybe some people have actually adopted that as your organization, in which case, at least this first part of this presentation will be kind of stuff you maybe already know. But if you actually want to have your organization adopt a CI/CD process, well, that's only going to happen. It's going to be built on a foundation of automated tests. No organization is going to be deploying any sort of applications out to production without having some sort of validation to make sure that they are meeting business requirements, that there isn't security issues, performance issues, and so on. And of course, for many organizations, that is a manual process right now, or at least many organizations I have been in. It was a very manual process where you would have your developers, you would commit your code, and maybe there would be an automated build process within it, and maybe even a deployment to testing to a test region. But from there on, it would probably be a very manual process in which you would have QA testers actually be the ones that are validating the correctness of the code before it goes to production. Maybe you have some automated tests, some unit tests in there that are running checks and stuff, but you're not really relying upon them as your gate to production. It would be really manual QA processes that are going to production. And of course, this is time consuming and labor intensive. Oftentimes it would take hours, days, or potentially even more to go through this testing process before you can get to production. Maybe accepting for when you maybe have that exception release because there's some major issue in production. And so it's all hands on deck, and, you can maybe get something tested in a few minutes and out to production, though it's also a very limited test, just to make sure that like the one line fix that fixes whatever is causing a problem in production is fixed, is tested. But oftentimes it's a very slow, labor intensive process that's time consuming and expensive. And the more subtle way this causes an issue, or at least the way I would often see a subtle issue crop up, is what I like to call the dependency iceberg. So particularly myself early in my career, we spend all of our time working on these applications at an organization, yourself, your team, and so on. And so at least I had a conception. It's like, oh, most of the code that's going after production is the code that I or our team has written. But the reality is it's actually only a very small fraction of the code running in production is actually the code that your organization has written. The reality is the vast majority of the code that's running out there is actually the code your code runs on. So, because the JDK would be a big one for all Java developers, but your application server, whatever frameworks, Spring Boot, Jakarta, Micronaut, Quarkus, and so on, that's going to represent a far larger code base than the actual code that you've likely written. 9 times out of 10, 99 times out of 100, probably to be more accurate. But within that, that's where you're going to have mostly where your security, performance, and feature issues are going to kind of come in, where, hackers and stuff, they're going to be more looking to say like, oh, okay, you're running on an old version of Tomcat and it has this security vulnerability, and that's how they can maybe get unauthorized access to your system or whatever it might be. That's what they're going to be probably more often looking for, rather than maybe some sort of security vulnerability that you wrote in your code, because that's going to be very hard for, in general, hackers to understand, other than maybe if you're so I live in Kansas City, and that's in the state of Missouri, and I don't know if it's making news over across the pond, but recently some SSNs were posted in plain text to HTML code, and that's causing, and like now our state governor is trying to sue the newspaper because they brought that up sometimes there are issues where your first party code where you're actually doing something wrong and creating a security vulnerability. But in general, a lot of times the security vulnerabilities is going to be coming in the underlying dependency code. And that's just where one of these subtle areas where this can build up when you're depending upon manual processes. They can create a big disincentive for upgrading your dependencies. So many organizations I've been at was often very, very far behind on the dependencies. Many places I've been at been like using Spring Boot, and sometimes we were whole major versions behind, several minor versions behind, whatever we were running. It was, 6 months, a year plus out of date with whatever the version we were on. And so there was just a big issue of security potential there. And the reason this was happening was because upgrading to a more recent version for these underlying dependencies, you just don't know what would happen. It'd be like, oh, okay, we are on Spring Boot 1.5.6 and 1.5.7 is out there. Or maybe the most recent is like 1.5.12. And I know, Spring Boot 1X is well out of date, but this is kind of just from past experience. And even though it's just like a minor patch version, many organizations or even just the developer themselves wouldn't necessarily want to upgrade that because you just don't know what would happen. Probably everything would be fine, but you don't know. And if you upgraded that and, then it would, if you said something, I say like, hey, I'm upgrading this, then it's like, oh, okay, we need to do a full regression test. And that's just going to be a whole lot of work. Or if you didn't say anything and, maybe things turned out fine and okay, you're good. But if something did happen, they'd be like, wait, Billy, why did you upgrade these dependencies? And maybe that's what caused the problem, or it could have been something else that caused the problem. So this is something that can slowly build up. I've seen a lot of organizations when you're depending upon manual processes. So yeah, the high effort regression testing your code disincentivizes keeping dependencies up to date. So by switching to a more automated process, again, you would still have overall the same process. So your developers commit code and then it'll be built and tested, but you would have an automation process that could typically maybe be measured in a matter of minutes from the code committed to when it could potentially go to production, or maybe a near production region where you would then have some sort of like simple, like, okay, we're going to deploy only at off hours to production to not cause any sort of service disruption. But also importantly, there'd be a much lower labor cost associated with that. You're not going to have to devote dozens of tester hours to checking to make sure that your dependencies didn't cause any sort of issues when they were updated. But there are a couple of other key additional benefits to automated testing beyond the speed and beyond the reduction in labor costs, which again aren't trivial. But two other really key ones is one, an automated test is, well, they're auditable. If you're relying upon a manual process, there's no way to generally be certain that a QA tester or the developer testing the code actually performed. You may script it out like, oh, okay, you need to do these 10 steps when testing your code, but there's maybe no way to always be certain that the person that tested the code actually did that. Maybe they thought they did, but they maybe did it in the wrong region. Or maybe when they did the test, maybe the code wasn't yet deployed, or maybe they just accidentally skipped a step without knowing it, or did something out of order, or did something a little bit different. Maybe they, when filling out a form, accidentally hit the space key for one of the fields. And, that obviously would cause the test to be a little bit different from, well, not doing that. Also, repeatability. Humans, we can kind of do the same thing, but we're not going to be nearly as good as a machine and able to do running through like the same tests, the same way, the same order and all that stuff. So if you were to run a test suite and an issue happened, well, you can rerun it to see, does it persist or does it go away? And obviously, if you have a flickering test, that's a problem, but you can also get a better idea of, is it the system being different? Is your code being different? Is it something else? Whereas it's a little bit harder to be as confident when you're relying upon manual tests, because again, you don't know if the tests were being run the exact same way both times. And of course, also you can maybe rerun your test suite against a different version of the code base. You could be like, okay, wait, if we revert back to like a bit older code base, does this issue persist or is it not there as well? And then you can see like, okay, no, this wasn't an issue back before, so we do know it's definitely a code change, or maybe it was also an issue back then, so we had to look somewhere else. It's not, something that changed in the code that caused it to happen. And last, how many automated tests should you be writing? And it's a bit of a cop out, but really it's whatever gives you confidence to deploy to production without some sort of manual intervention. Because sometimes, and I think, broadly, the automated test community has known to kind of move away from some sort of arbitrary, you need to have at least like X percentage unit test coverage or code coverage. But, really it's what gives you confidence to get to production, because, well, along with code coverage not always being a good marker for it, it's also just going to change a lot based upon the needs of your organization and really the needs of the individual application. The same organization, you're going to have different applications, going to have different levels of criticality. You could have some sort of internal batch process that runs weekly that, isn't really just maybe kind of reconciling whatever makes sense at your organization. That's probably not as critical as whatever main application you have running that is maybe processing credit card information. That's much more important than maybe like a weekly process. So that process that's, processing payment is going to need to have a much higher bar of automated test suite around it to get to production without some sort of manual intervention than maybe this internal batch process. So it's whatever gives you as a developer, you as an organization, confidence that, hey, I commit code, these tests are going to run, and then it's going to go to production, or it's going to go to whatever closest to production region. And then you just maybe have some sort of person say like, okay, we will push it out at off hours or whatever it might be. But whatever gives you that confidence without some sort of manual intervention, manual testing, that is the amount of automated tests you should write. And, well, I guess really no more beyond that, because then you're just creating an additional maintenance burden on yourself. With all that said, there is still a role for manual testing, even in an organization that is extremely mature, extremely advanced with automated testing. You would still need some manual testing in there, but it's not part of the steps that you get to production. It's something that's maybe kind of always happening in background in parallel, like a dog fooding, perhaps, if that makes sense, if that works for your organization. But it's exploratory. It's like, oh, what if I just do these steps in this order? Or what if I, throw this at the system to see what happens? It's just kind of going to be happening in parallel to development. And if anything comes up, obviously, then, you add that as an issue to be fixed, and you write some manual or you write some automated tests to then cover maybe this new test case that you weren't covering before. But it's just not a step. It's not going to be like, hey, before we go to production, we need to do some amount of manual exploratory testing before we go. All right. So this is why you should be concerned, or why you should care about automated testing. But then, all right, how can we become a automated testing superstar? So there's two first kind of mentality things to think about. First is to treat test code like production code, and then also make sure to make a real effort towards writing human readable tests. Again, certainly when I first started learning about automated testing, like I just kind of thought like, oh, it's just test code, whatever, just pound it out, whatever, and just type it out there. It doesn't matter about maintainability or readability or anything like that. Just write it out and don't care. And of course that then creates maintenance efforts later on. It can also, both in that it can be hard to change the code, and then it can also be hard to understand what the test is trying to accomplish. And of course, that also goes right into writing human readable tests. You need to be able to understand what a test is trying to accomplish. That, of course, makes it more auditable as well. So when a test is failing, or maybe a bug is happening in production, you're trying to figure out, how did this get to production? you need to have tests that you can go back and look to see like, oh, okay, well, actually, we thought we were checking this, but we weren't. So now we need to update it to make sure we are checking it, or maybe it was checking something incorrectly, or whatever it might be. By writing tests that are actually readable, so you actually know what it's trying to test, helps a lot. So one way that can help a lot is by using assertion libraries. So by default, like the assertions that come with JUnit, whether it's you're using JUnit 3 or 4, or even if you upgrade to actually using JUnit 5, the assertions aren't so great. I think the one that most typifies this is the one we also use most often, which is assert equals. And I know for like years, I actually think I was using assert equals incorrectly. So assert equals, the expected value is supposed to be on the left and the actual on the right. And I think, like I said, I think for several years, I actually had it the other way around because that's just what seemed most natural to me. But it's always unclear. There's no objectively right way the JUnit team could have written this. So, it could always just be a little confusing. And once you maybe have a bunch of different assertions in there, it can be sometimes difficult to understand what exactly is going on, or if you have more complex assertions. So, my experience when I'm using assertion libraries is AssertJ. There's also Hamcrest, and I'm sure there's others. I'm not necessarily saying which one you should use, but I would highly recommend using an assertion library instead of just relying on the defaults that are provided to you by JUnit, because it becomes much more fluent. So here it's just a simple, like kind of the same thing of like assert that, and then you have the actual, and then is equal to whatever your expected value is. It's just a much more fluent way of writing that out. And I think we'll take a look at that a little bit later on in some live coding of that. I think I have some examples pre-set up. And also, this isn't really a knock either against the JUnit team. Part of the reason why they really haven't devoted too much time to improving their assertions is because of the availabilities of these libraries. So it's just like, why should they take this time to change up their assertion behavior when it could just be much easier for developers out there just to bring in some third-party library that actually matches with their style for what they're looking for. So that's also a bit of why the base assertions with JUnit aren't necessarily the greatest. Also, I would highly recommend upgrading to JUnit 5, and we can also take a look about that as well. In the code examples, it's been just over 4 years now, but if you're still in JUnit 4, you're definitely missing out on a whole lot of new features that come in JUnit 5. Parallel test execution, repeated test, the whole extent, like, so JUnit 4 has like run with, extends, and all that. And rules, and that has all been redone with the new extensions API, which is a lot more consistent and a lot easier to use. Also, if you need to selectively disable tests, again, that's much better on JUnit 5. Because JUnit 5 was written with Java 8 in mind, things like disable our default test methods and interfaces are available, which can be very good for patterns, for developing testing patterns. Test ordering, I mean, there's a lot more as well that comes in JUnit 5, and we can take a look at that as well. Particularly, like, I don't know if anybody wants to kind of put into the comments if they've upgraded to JUnit 5 or are thinking about it. Definitely put into the comments. I will make sure to actually take some time to kind of go through that as well. And then the other important part is to write reliable tests. So if you take your time, you have this really nice automated testing suite that covers all your code and all your applications, but it's not reliable. Well, that's going to reduce a lot of confidence in actually relying upon them. So unreliable tests would obviously be tests that like sometimes pass, but then sometimes fail. And it's not necessarily anything to do with the actual code that you're testing. So when you're relying upon external services, that is often the biggest area where the unreliability can come from. So if you're calling out to like a database, maybe that database is down in the region that you're calling for maintenance. Maybe the data goes missing. Maybe it's been configured differently. Maybe that region isn't configured with how it would actually be when it's in production. There's a whole lot of things that are there that could easily cause you to lose confidence in your tests. That like, okay, these tests. Thanks, Nick. About JUnit 5 and Assert J. There's a lot of things there that can cause you to lose confidence in your automated test. That they could be all returning green, but you can't really rely upon that. Or it fails, but it's like, oh, okay, actually it failed because, well, the data was gone, and so we'll just ignore that failure and put it to production. And then you actually go to production and you actually find out you have a bug, that it wasn't the data was missing. It was like, oh, this was really wrong. Or maybe it did fail because the data was missing, but there was also some other error there. So having reliable tests is also critical as well. So how do we do that? Particularly, again, as virtually every application is going to depend on some sort of external service. So one of the best generic options, and something that I'm very happy to see becoming increasingly popular, is test containers. I think it was released in early 2017, maybe 2016. But what test containers is it allows you within the life cycle of a test, of a JUnit test, to spin up and tear down a Docker container. And of course, since a Docker container can basically run anything, whatever sort of external service you need to run, you can use test containers to simulate that. And then with test containers, do I actually have that? You can test against your local containerized environment. So that way you don't have to worry about that external service being down, or misconfigured or anything. You can set up your Docker container to automatically inflate it with whatever appropriate test data that you need for running your tests. So you don't have to worry about test data going missing because some previous service our test went in through and deleted it, or someone was doing manual processes and integration or your QA environment and deleted it, or whatever it might be. And you can also write these scripts out to make sure that data is always fresh with whatever current you need. You need some number of users that have created accounts in the past week. Well, then you have your automated script that, go ahead and, keep something current within whatever time period you might necessarily need it to be. Also, with test containers, with Docker containers, you don't have to worry about administrating a local instance of whatever service you need, which can be very burdensome. Whatever database instance, running a local database instance on your local machine, that can take a lot of effort to get it installed, and then to also make sure that it matches with whatever environment you want it to be in. With test containers, you could have your own local, with organizations, you could have your local container registry instance that has a container or an image that matches whatever appropriate region that you want to be testing against for whatever service you're using. So it's like, okay, we're using MySQL, I haven't keep up on MySQL, whatever the version of MySQL that you're using and all that, and then you can also have it to where that it matches all the different table structure and all that in that region as well. You can pull down an instance of that. You can have available volumes test data out there as well that can, give it the appropriate information to then run that test. But it's all much easier than, again, trying to run and maintain your own local instance, which can just be at an individual level very difficult, and at an organizational level, you won't say impossible, but again, very, very difficult to actually accomplish. Not that necessarily this is easy, but it's much more achievable than trying to rely upon all your developers, maintaining local instances of these services. So test containers is great, and it can cover most any use case. Another feature, another tool, I haven't had too much experience with it yet, and it's only still, I think, maybe an alpha or beta, and it only kind of went to that kind of public beta, public alpha, public beta kind of transition back in the summer of this year is JFR-Unit, which stands for JDK Flight Recorder unit testing. And what that allows you to do, so one area within automated testing that was always very difficult to accomplish is performance testing, because like you can run like a load test against your application in your test region, but it's always difficult to know, does that actually match up with what it would be doing in production? If your database and your application server are in the same region in your test region, or maybe they're in different regions in your test region, like different geographical regions, that's going to have a dramatic impact on network communication. So that's going to throw off all of these tests on how they depend upon that for how long like it takes to do throughput. Or you could have things where maybe your test region is going to have much less resources generally than your production region. And you might run into bottlenecks that don't represent what would really be a bottleneck in production. Like you might run into a thread bottleneck in your test region, but in production, threads may not be an issue whatsoever. And it's really would be memory that could be an issue. But then you try to optimize around threads because that's what you're seeing in test, but then you get to production and that's not an issue at all. So what JFR-Unit allows you to do is the JVM through the JK Flight Recorder emits a lot of events, and you can track those events to see how those might be changing in your code over time. And because you're depending upon the JVM, as long as you're using the same JVM versions that you're using in your test region as you are in your production region, then they should be pretty consistent. There could still be some differences if you're using something on Windows in your test region and you're actually running in Linux, there could be some differences, but it should be much more consistent than what is possible before. And then like here, like this is just a very simple example of like these object allocations. Basically, this is just tracking how often the JDK or the JVM is allocating new objects internally, and this could be a way of tracking memory usage and also to some extent performance as well, because allocating a new object in the JVM does actually take CPU cycles, which would impact your throughput performance and so on, and also that would be more garbage collected and all that. But this is a way of kind of having a more reliable way of doing performance tests over a period of time. If you start to see these things change, you can be like, oh, okay, the code we're having an issue where we're allocating a whole lot more events. Or if you made a change to your code that you're trying to address this, you can see like, oh, okay, yep, object allocation is much lower now than it was before. So it's a bit more reliable than kind of doing these performance tests on live systems where there could just be a lot of factors that either might change between time, there could be more network activity that could kind of throw your performance test off, or it doesn't maybe accurately represent what's actually happening in production. So exactly. Sometimes I kind of forget that I have some of these little bullet points later on, but it's kind of exactly what I said, tracking JFR events that are emitted by the JVM, and it can just be somewhat more consistent across environments because you're looking at exactly what's happening internally within the JVM instead of like a more live system look. The last thing I want to cover, particularly for integration testing, is contract-driven development. My experience with contract-driven development is through Spring Cloud Contract, but there are other options out there that go beyond the Spring ecosystem. One of the big examples would be Pact, I know, but I think there's a few other examples as well. And actually, I know Spring Cloud and Pact are actually compatible, or at least Spring Cloud Contract is compatible with Pact. So if you're already using that and you want to try something else, you can do it that way as well. But what contract-driven development is you write out a code executable contract that can then both test the service that it's written to represent against to make sure it's actually meeting the contract. And then also in most cases, these contracts can then be used as a stand-in for the service to make sure whatever clients can communicate with the service without actually depending upon a live service. This is an extremely simple example of a contract written in Spring Cloud Contract in this case using YAML, but it's like, okay, I'm going to make a GET request. I'm going to make it to this URL or this API, and I should expect back then a 200 response. In this case, just getting a GET for everything that's considered an apple at this service. And the body of it, I should be getting back a couple of items of different apples that have like different quantities. And you can also then do things like checking the headers to make sure that I'm getting back JSON that's maybe as UTF-8. But yeah, you can check. Contracts should allow you to kind of check all these different things. Spring Cloud Contract can also allow you to do for messages services. I haven't actually personally done that yet. And from what I hear, this is actually maybe a couple years old now. It doesn't work quite as well, but it's there, it's still there. And I imagine you can also do with other contract driven or contract testing tools. But pretty much then this allows you to, you can run this contract to make sure the service that is supposed to be representing this produce service is actually meeting this contract. And then you can also, at least Spring Cloud Contract allows it to read in these contracts and then create a mock service based upon it to where that you can test that against as well, which again kind of helps avoid those issues of if you're testing against a live service of test data going stale, that service being down, that service being overloaded or whatever that could cause your test to fail that don't actually have anything to do with any sort of code change within the application. And so then again, that leads you to lose confidence in your automated test suite. And also these could, possibly be run a whole lot faster as well. That potentially also sometimes being the case maybe with test containers or even JFR-UNit, where at least if not necessarily faster, the execution time should be more consistent because you're not maybe running into an issue of a live service being overloaded or the network being overloaded, suddenly causing your automated test suite to perhaps run much longer. So I do have available code examples for a lot of what's covered here. So I need to actually kind of get some of my JUnit 5 stuff a little bit up to date. They recently released 5.8, which I don't think I have really any examples that are unique to 5.8 in here. But for several years, I was talking on JUnit 5, and I kept it at least up to date, I believe, to 5.6 here. So you can see a lot of the new features added to JUnit 5 over that time that maybe weren't available in JUnit 4 available here. Also, if you want to see an example of contract-driven development, at least a little bit of a simple example available, you can also check this out here. As I mentioned, I only have very limited experience so far with JFR-UNit, so I would definitely just recommend the JFR-UNit home GitHub repository, and that was put together by Gunnar Morling, which also has examples available as well as documentation. So we have some time. I can go into some code examples if people want. If anyone wants to put into chat maybe any particular area to do some code examples, or also people can, if they want, unmute themselves or have any questions, I'll be more than happy to answer them at this point.
I can't see any questions in the chat, but I've got a little question for you.
Okay.
So in one of the examples, I saw there was a bit of kind of mocking in there. I'm probably using Mockito or something. So I'm just wondering what your thoughts are around kind of the use of mocking, how much you should mock, that kind of stuff. I know I've had mixed experiences when it comes to mocking in the past. Yeah,
and actually that is one area I'm definitely pro using mocks. And it's one area I kind of wanted to put it into this presentation, but have had trouble putting into words, concisely writing about how I want to do that. And I think sometimes the issue people have when it comes to using mocks is like they end up mocking the layer that's under test. So like, let's say you have your controller layer that you want to mock out to say like, oh, kind of like you would be maybe the case here with this like cloud contract, I would want to mock out my controller layer when testing this, not necessarily having to have a whole live service for this contract to test against, because again, for liability reasons. But I think sometimes what often happens where the frustration comes with mocks is, so like I should only be mocking the layers below the controller layer. And then sometimes people will write mocks where like the layer that they're actually testing is being mocked itself. And then what you end up is then you're asserting against the mocks. So maybe a more easy example could be with like a database. It's like, what if I send something and that's supposed to cause an exception in the database? Like, you don't really care, and you want to make sure then that your database code, the database data access layer code, is handling that exception well. You don't really care how that exception's happening. You just want to make sure that if your database throws an exception, your code handles it properly. Like it ends a transaction, it rolls back your transaction, and sends appropriate error message or whatever makes sense. That's a good example where a mock can be very helpful, just to say Mockito is like, oh, throw a SQL exception and just throw it. It doesn't really matter if the preconditions are correct. You just want to make sure that if an exception is thrown, you're handling correctly. And maybe where people get into trouble then is like the within that data access layer, how you roll back that transaction. You start mocking that transaction itself in your code, and then that's when you start testing the mock itself, and then it doesn't really represent what would be happening in your code. And I think that's a lot of times where that people start to run into that issues. They start to mock the layer under test itself instead of the layers below that you're dependent upon. And I mean, and it can be easy to kind of get into that. I mean, no matter
I've done
how, yeah, exactly. I know I've done that plenty of times. And, maybe that was a little bit when I was a little less familiar with automated testing, but even since becoming much more familiar with it, I'm sure if I went back to pure engineering and working on a real production database or production application, I would make that mistake as well, just because we're human, we're not perfect. But I think, again, mocking can be a great tool, and it just comes with discipline, just to make sure you're not misusing it.
Cool.
Yeah. Any other questions? Or I said, I have a few minutes. I can do some live code examples. So there's like a particular area people would be interested in looking at as well, that maybe they're not familiar with. Maybe one that could be worth it, just to show maybe how it would actually work, is with test containers. Because I think that's probably one of the areas that really solves some issues for a lot of developers. So certainly, I know there have been plenty of times where I would have killed probably to have been able to have access to test containers. Let's see, I have it somewhere in here, I'm pretty sure. Yeah. Oh yeah, repo, that's where it is. And this might be slightly out of date. It's always kind of difficult to kind of keep all of these test examples up to date. I know somewhat a little bit back, I kind of updated it because there had been a couple of major versions of test containers released into interim. But we can see here, let me make the code a little bit smaller so it's a little bit easier to see everything that's going on. But you can see like here, I'm calling out to like a pre-configured container, like in this case, like a Postgres database. And it's like in this example, I'm using like a hotel, and it's like, okay, the hotel database one, and then the latest one. But of course you could sit here and say like, 1.1, And then out within your organization's container repository, like your database team could be maintaining a database image that matches whatever appropriate regions that you're running a test against, whether it's test, production, or whatever it might be. You can have that. And then of course you can pass this in to be configurable to, have your test server say, hey, okay, we're going to test against the test region, or we're going to test against the production region, or whatever it might be, to kind of match that up with it. And then, you have the pre-configured database that has all the correct structure set up for it. And then you can have something in, some available scripts that could be out there that can then populate it with whatever appropriate test data. And then here you can, whatever you need to go through to then connect to that database within your container locally is available as well. I do know, and I don't know if I have it within this, one nice change the test containers team eventually made, and now it's probably about a year or two old, is before, like for each test, it would build up and then tear down your test container, or maybe between classes. But now you can actually share a test container, I think actually even across classes, across like maybe your entire automated test suite, which can save a lot of time, because setting up and tearing down a Docker container, can take some amount of time. If you're doing that potentially dozens of times, that could really increase the runtime for your automated test suite. If I can run it here. So that's also one nice change that they made, and that's maybe within like the past year or two that they made that. So it's I'm maybe a little bit out of date. Forgot to get Docker started. We'll give that a moment to start. What we can see then. Yes, go ahead.
Got a question there, yeah. So Dave has asked, how do you configure the container runtime environment? Do they just run in a local runtime environment?
How do you configure the container run? So are they talking about like the versions and all that of Docker, or like to make sure like the data and all that set up correctly, or how do you configure the container run?
You're a bit quiet, Dave.
Yeah. If you want to expand upon that, just to make sure I'm reading it correct, understanding it correctly.
Yeah, so I've never come across kind of like running containers.
Can't quite hear you, Dave.
Yeah.
On that, your mic's really quiet.
Is that any better?
Oh,
it
perfect.
Is. All right, sorry.
That's all right.
So yeah, I've never really come across like running containers from code before, or running them from an IDE even. So I was just wondering, so obviously spinning up containers that going to run tests, so is that just like you're running on your laptop's Docker runtime?
Yes.
Is there some kind of settings you have to put in your IDE, or?
So you don't have to do, so like that's all really handled by test containers. So, I mean, you're seeing everything here other than, bringing in the test containers library of what I need to do to use it, for it to call out to Docker and to run it. So like you can see here, it's saying like, it's calling out to Docker to set it up. And I may not have my local system or my Docker containers all set up correctly. I built this example out a couple of years ago, and I haven't always kept it up to date. I need to get my Docker login and all that stuff set up. So sorry, I don't have that test immediately available. But yeah, Docker or test containers actually handles all that communication for calling out to your Docker, and then, saying like, oh, okay, find Docker on your local system, and then tell it to, bring down this specific version of a Docker container, and then, run your test against it. So like, that's honestly like one of the really nice, I mean, granted, I've mostly only done it with proof of concept work. Haven't done, a true real world, money depends upon it examples with it or work with it yet, but test containers is very easy to work with. Like I said, to me, it just works kind of as expected. Like, you know, you go through, you set this all up, and sure enough, it will go down, pull down this Postgres, you know, instance that I need, and run it and run the test against it. And, you know, you can, there's other things you can do again to like make sure the data like gets supplied to it as well as part of like the setup steps. But yeah, there's no special IDE configurations or all of that. You just need to make sure that you have Docker set up, and also make sure to have it running on your system at the time.
Great, thanks.
Yeah. All right, cool.
It's interesting. It's test containers isn't something I've played with in anger, but I suppose historically I'd always have kind of reached for like an in-memory kind of, you know, interpretation of that database. And I suppose at that point, it's not the real thing. It's trying to be the real thing, and you're running that kind of risk, aren't you? That there is differences that are, you know, so test containers is giving you this extra guarantee.
Exactly. Yeah, because that's also what I've done before. Like I've used like H2, which is, I'm guessing, kind of the very popular in-memory database, and like I have nothing against H2, but ultimately it's exactly what you're saying. It's trying to, you know, it gives you choices to simulate a Postgres database or Oracle or MySQL or SQL Server database, and, you know, probably for 95% of the use cases, it does a good job approximating that behavior. But every organization has some code out there that depends upon that 5% of other use cases, to where, you know, you have some sort of internal processes within that database that just H2 can't really simulate quite correctly. And then it kind of gets you back to the point to where you can't really rely on your test, or you need to actually call out to your test database, which or your test region database, which then kind of gets back into the issues of test data going missing, you know, stuff being out of date and stuff like that. This gets you much closer, because you can, again, if your database team, a development team, is taking the time to make sure you have like proper images of your database out there running, then you can actually be like, we're running against the exact same version, against the exact same configuration and all that. So you can have as a much higher confidence that what your test is doing is going to simulate the reality of the region you're supposed to be testing against, or, you know, whatever in production. Again, you know, haven't done that in anger, but I can definitely see that much more easily out there. And I've definitely done like H2 in anger, and at least ran into those issues a few times, because one particular thing I ran into that I couldn't simulate was what would happen if I lost connection to the database and all my connections went dead, and then they wouldn't restart. Like I couldn't simulate that with H2, and I would actually need like a real database example to go against, which I could have done with test containers, but I just didn't have at the time. So like that's one example where H2 wasn't able to properly simulate that behavior.
That's cool. Kind of, there's another question that kind of comes to mind, a bit of a follow-up to this. Then. So interested in your kind of thoughts around, I suppose, like with test containers, we're writing much more integrated tests. And obviously there's these different scales of, you know, quite, you know, small focused unit tests all the way up to like system tests. And just wondering kind of your thoughts around that scale of different types of tests. You know, would you favor one kind of type of test over another? That kind of thing.
So integration test versus unit test, I think they all have their particular purpose and level. So like, and some of this would always come back to, you know, time and effort, you know, being very academic and writing out these unit tests to all these different levels, and then having integration tests beyond that, you know, would obviously be the most preferred, but that may not always be practical. So, you know, writing a few big integration or end-to-end tests that kind of cover stuff from begin, you know, from end to end, you know, can give you that broad coverage, but you're going to obviously lose a little bit of granularity. So yeah, it would be best just to write your integration tests that narrowly cover that integration layer between the services, and then using unit tests to kind of actually cover the more in the actual more business behavior of your service would be the best. But again, that can be a very abstract or ivory tower perspective of it that may not always match up with the realities of having to get code out to production. All right. Unfortunately, I think I need to drop here in a couple of minutes. I have a meeting I need to get to, but
yeah, sure, that's fine.
Yeah, thank you so much for inviting me, and hopefully we'll be able to do it in person next time. But yeah, thank you for everyone for attending, and I'll make sure I get my slide deck up to date. And again, if you have any questions, shoot me an email. Let me get my slide deck back up here. But yeah, shoot me an email at billy.korando@Oracle, or reach out to me on Twitter, where I spend way too much of my time. Don't tell my boss. But you can shoot me a DM, and I'll be more than happy to answer any questions you have at Billy Korando. But yeah, thanks again, and hopefully be able to see each other in person sometime soon.
Yeah, sure. Cheers, Billy.
Cheers.
Yeah, thanks everyone for coming. This has been recorded, so this will be up on our YouTube channel. Search for Manchester Java Community on YouTube, and we'll share that via our Twitter handle.
Great.
In the next couple of days. So yeah, thanks everyone.
Thank you.
Cheers,
Bye.
Billy. Catch you later.